MyMathLab Chapter 4. I just wanted to go over some of the problems, but exponential. To be exponential, the variable needs to be in the exponent. So x to the fourth will resemble a parabola. This is linear. But this one is exponential because the x is in the exponent. So e would be exponential. This is quadratic. It's a parabola. And then d is exponential because the x is in the exponent. And the last one is not exponential because 4e is just a number. X is not in the exponent. So it would only be d and e. To determine if it's a growth or a decay when it's exponential, you want to look at the number. And like this one would be a growth because it's 2. This would be a decay because it's 0.6. So if it's between 0 and 1, the base, it will be a decay. If b is greater than 1, it's a growth. So this one is a growth, this one is a decay. Now I skipped the other two because of the negative exponents. What the negative exponent does, if we have 4e to the negative 2x, that negative moves the e to the denominator. 1 over e to the 2x. Well, that's less than 1. So it's actually a decay. The same thing here. It becomes 1/3 2.4x. So you need to be careful with the negatives in the exponent. Make that positive first, and then you can use this rule. Graph the equation on paper and then choose the correct one. We learned graphing with Desmos, so you would just plug it in on Desmos. But exponential grows like this, and then the 3 is going to move it up 3. This is at 1, 2, 3, 6. So it would be C. But you would just plug it in on Desmos. The purchasing power decreases if inflation is present in the economy. For example, the purchasing power R after T years of 8% inflation is given by this model. What will be the purchasing power of $50,000 in 10 years? So P is purchasing power. R is the amount of money, so we're talking about 50,000. To the 10 years. And then you just plug that in your calculator. $21,719.42. Rewriting logarithms to an exponent, start with the base and loop around. So this would be 3 to the b equals a. Writing a logarithmic equation. Now when it's a natural log, natural log and e are inverses of each other. So if you take both to the e, this will cancel. So we have e to the y equals 12x. Write the exponential. This one, again, it's similar to this. So to rewrite it as a log, start with the base and loop around. Log base 8 of x equals y. Next one. This one's the same thing, start with the base and loop around. So log base 2 of 8 equals 3. These ones I just want you to evaluate with a calculator. When there's no base, it's a base 10, and base 10 is what your calculator uses. So you would click on log 3. Round 3 decimal places. 0.477. Natural log 52. 3.951. And log 61560. 4.789. Okay, finding the value without a calculator, we'll do a couple of them. Let's do log base 7 of 49. First thing you want to do is rewrite it and get rid of the log. So that would be 7 to the y equals 49. Then you want to write them as the same base. 49 is 7 squared. If you have the same base, then you can set the exponents equal, because b to the x, if b to the x equals b to the y, then x equals y. So since these are the same base, y equals 2. And that's how all those are in that section. This one. Log base 5 of 1 over 25. So start with the base and loop around. 5 to the y equals 1 over 25. Now just like this one, we need to get them the same base. This is 5, 25 is 5 squared. But this is in the denominator, so we need to move it up. 5 to the y equals 5 to the negative 2. Now we have the same base, so when you move something up, it changes the sign of the exponent. Now we have the same base, y equals a negative 2. This one here, the natural log and the exponent, remember they're inverses, that cancels and leaves 2. This one here, remember when there's no base, it's base 10. So then we would rewrite it. 10 to the y equals 0.01. This would be 100th, 1000th, which can be written as 10 to a power. But now it's in the denominator, so we need to move it up. Bases are the same, y equals a negative 2. when the log and the base are the same, they're also inverses. You can cancel them because the formula is log base b of b to the x equals x, or b both of these. And so we have this case here. It's just 5. Breaking them up, the first thing you want to do is rewrite the radical. So 5x plus 7. Remember, a radical is a fractional exponent, so that would be 1/4. Then you can break them up. So we have the log base 4, 5x plus 7 to the 1/4. Now these two are in the bottom, the 5 and the x squared, so they're subtracted. Log base 4 of 5 minus log base 4 of x squared. Then you want to bring your exponents down in front, which would be this one, because we'll bring the 1/4 down. Log base 4 5x plus 7, and then I have them in the opposite order, but remember, order doesn't matter as long as you take the sign with them. You can add or subtract them in any order. Bringing the 2 down. There you go. So it's to rewrite it, bring the exponent up first. So the natural log x plus 8 to the 9th minus the natural log of x to the 4th. When you're subtracting, it becomes a division. The positive one's on top, x plus 8 to the 9th, and the negative one goes in the bottom, x to the 4th. Solve the equation. $1,600 cannot be written as 10 to a power, but we could rewrite this. The log base 10 of 1,600 equals x. And then base 10 is your calculator, so you could plug it into your calculator because it did ask for a decimal. Since this is base 10, your calculator uses base 10. So log 1,600 3.20 thousand, 1/10,000, 3 decimal places. Solve the equation. Oh, we're going to do this one in class. Use a change of base formula to evaluate the algorithm. A change of base would be, and you can use log or natural log, but natural log of the square root of 6 over natural log of 2. Or you could use log square root of 6 over log 2. Either one. So natural log square root of 6 divided. Make sure you close your parenthesis. Natural log 2. 1.4 decimals. 2925. And if we use log square root of 6 divided by log 2. Same answer. These two, similar to same base as we did before, 8 can be written as 2 cubed, and an exponent to an exponent is multiplied, so it would be 2 to the 3 times x. And 16 is 2, 4, 8, 16 to the 4th. Now we have the same base. 3x equals 4. Divide by 3. X equals 4 thirds. So there's a lot of different versions when you're solving these. The more you practice, the better you'll do. So if we look at 3 times 5 to the 2x equals 46,881. Well, first thing we want to do is get rid of this 3, so the exponential part's by itself. So we'll divide by 3. Now, this will not be 5 to a power because it's ending in 7. When you cannot get the same base, you can take the natural log of both sides, because then that 2x can come down in front. So you have 2x natural log of 5 equals the natural log of 15627. Now we want to get x by itself, so we can divide by 2 natural log of 5. So x equals the natural log 15627 divided by 2 natural log of 5. So this would be the exact value. They want the estimate. Plugging it in, natural log. Round to the nearest whole number. The reason I said that is it's 3.00000, so it's just 3. Solve the logarithmic equation, rewrite it to get rid of the log. 6 to the 4th equals x, and 6 to the 4th is 1296. Solving this one, the first thing we want to do is get the natural log by itself, so we'll subtract the 5, divide by 2, and to get rid of a natural log, you can take it to the e on both sides, because these are inverses. It's x e to the 7th, and they want the exact value. They want e to the 7th. If you did need the estimate, E is where your LN button is, so it would be second E, and then 7. Okay, this one we'd want to get our natural logs on the same side. So we'll subtract the 3. Then we're going to add this one to the other side. The natural log of 8x plus the 2 natural log of x equals 21. Because that way then we can use our rules to combine these. Because it's an addition, it becomes a multiplication. The natural log of 8x times x is 8x squared. Get rid of the natural log, take e of both sides, so that 8x squared equals e to the 21. Get rid of the 8. And then take the square root. Now remember, when you take the square root, it leaves plus or minus e to the 21st divided by 8. Type your answer using e as needed. So they want the exact value again. This one, we could combine these first. Remember, addition's a multiplication. So log base 6, 8x equals 1. Rewrite it. 6 to the first equals 8x. Divide by 8. 8 equals, dividing 3/4. So x equals 3/4. We're going to do that in class. Yeah. 25. After the end of an advertising campaign, the daily sales of product fell rapidly, with daily sales given by S equals 3900 e to the negative 0.05x, where x is the number of days from the end of the campaign. What were the daily sales when the campaign ended? Well, they would end when x is 0. E to the 0 is 1, so you'll get 3,900. How many days passed after the campaign ended before the daily sales were below half? Okay, so we'd want half. The 39, half of 39. So we want the sales to be half. Get E by itself. To get rid of E, we take the natural log. And then divide to get x by itself. Natural log of 0.5, close your parentheses, divided by a negative 0.05. X equals, round to the nearest day. It's 13.8629, which would be 14.